Top 5 coolest looking rocks ever found. So the world of rocks is a pretty fascinating one. It might just seem like a lifeless mass. However, for those who are interested in rocks, this video will be extremely interesting for you. Minerals have been some of nature's most stunning creations, and they can be some of the sleekest looking, most magnificent, and distinctive objects on the planet. Number 5. Fluorite. Fluorite is, also known as fluorspar, is a calcium fluoride mineral. It's a type of halide mineral. Even though isometric cubic crystallization is prevalent, octahedral as well as more intricate isometric forms are also common. Fluorite is defined as value 4 on the Mohs scale of mineral hardness. This scale is premised on scratch hardness comparison. Fluorite seems transparent and colorless in ultraviolet and visible light when it is pure, but impurities turn it into a colorful mineral with ornamental and lapidary applications. Fluorite is often used as a smelting flux and in manufacturing some kind of glasses and enamels in industry. In addition, fluorite is a source of fluoride for the production of hydrofluoric acid, which would be the transitional source of most fluorine-containing fine chemicals. Because visually clear and transparent fluorite lenses tend to have low dispersion, they also have less chromatic aberration and are useful in telescopes and microscopes. Fluorite optics can also be used in the ultraviolet as well as mid-infrared ranges in which regular glasses are very opaque. Purple, golden yellow, lilac, green, pink, blue, brown, and champagne are the colors in which this rock is found. However, the cause of the colors is rooted in the impurities that are found in them. Fluorite is a common mineral found in over 9,000 locations worldwide, including South Africa, China, Mexico, Russia, Mongolia, and Spain. Number 4. Uvarovite. Ca3Cr2SiO43 is the formula for uvarovite, a chromium-bearing garnet group species. It was founded in 1832 by Germain Henry Hess, who decided to name it after Russian statesman and amateur mineral collector Count Sergei Semenovich Uvarov, 1765 to 1855. It belongs to the granite group, including the calcium-bearing garnets, andradite, and grossular. Uvarovite is the rarest of the widely known garnet species, and it is the only one that is repeatedly green, with nothing but an emerald green color. It comes in the form of well-formed, fine-sized crystals. Serpentinite, metamorphic limestones, chromite, and skarn ore bodies are all common places to find uvarovite in solid solution with grossular or andradite. The most important source of uvarovite in the past was a now-defunct copper mine in Outokumpu, Finland, from which most museum specimens were obtained. The chromium-rich silicate phases associated with volcanogenic copper-cobalt-zinc sulfide ore deposits in the Outokumpu district include uvarovite crystals. In the U.S., uvarovite instances are mostly found in the western half of the country, including New Mexico, California, and Arizona. Uvarovite has indeed been revealed in Lancaster County, Pennsylvania, in the eastern U.S. Eastern Cuba has also been confirmed to have the mineral. A heavy mineral portion of bulk stream sediment HM10 accumulated in Bunker Hill Creek underneath the historic Bunker Hill gold mine south of Nelson, BC, Canada, contains 9 grains of uvarovite. Its origin is likely to be close to argillaceous limestones and serpentinites, about 450 meters upstream from the silt site. Røros, Norway, Valmalenko, Pitkaranta, Finland, Italy, Pico deposits near Kipdaglari, Venask, Spain, Turkey, and Bezerk and Sorani, Russia are some of the prominent European locations known to contain uvarovite. In addition, uvarovite has been found in the Bushveld igneous complex in the Transvaal province of South Africa and the Vumbu schist belt in Botswana. Uvarovite has already been reported in Taiwan and Japan and Asia. In addition, uvarovite has been discovered in chromite reserves in southern New South Wales, Australia. Number 3. Tourmaline. Tourmaline would be a boron silicate mineral containing potassium, magnesium, iron, lithium, sodium, and aluminum elements. Tourmaline is a semi-precious stone that comes in various colors, including brown, black, green, red, yellow, orange, blue, pink, and violet. Tourmaline has a trigonal crystal system and is a 6-membered ring cyclosilicate. Tourmaline can be discovered in metamorphic rocks like schist and marble and granite pegmatites. The specific gravity is 3.06 plus 0.20 minus 0.06, and the Mohs hardness is 7 to 7.5. It takes the form of long, skinny to thick prismatic, as well as columnar crystals with triangular cross-sections and striated faces. Hemimorphism refers to the asymmetrical fashion of termination at the tip of crystals. Aplite seems to be a fine-grained granite with comparatively tiny, slender prismatic crystals that often form radial daisy-like patterns. The three-sided prisms of tourmaline are unique. Really, no other familiar mineral does indeed have three sides. Heavy vertical striations on the prism face frequently generate a rounded triangular effect. Hardly ever a tourmaline is perfectly euhedral. The delicate dravite tourmalines of Yinithara, Western Australia, are the exception. The reserve was found in the 1970s, but it has run out of resources. Hemimorphic crystals all seem to be piezoelectric and frequently pyroelectric. Number 2. Crocoite. Crocoite is a mineral made up of lead chromate crystallizes in a monoclinic system. Crocoite is commonly encountered as huge, well-developed prismatic adamantine crystals, inadequately terminated in several cases. The crystals are translucent and vibrant hyacinth red in color. The streak is orange-yellow with a hardness of 2.5 to 3 on the Mohs scale and a specific gravity of 6.0. Crocoite crystals have been discovered in Mount Dundas Extended Mine and the Adelaide West Comet, Red Lead, Platte, and a few other Dundas mines. This one was found in 1766 at the Berezovsko deposit, Berezovsk Mines, in Ekaterinburg, Urace, and given the name Crocoise by F.S. Budant in 1832, as from Greek O krokos, saffron, in obvious reference to its color. Its name then was later changed to crocoisite and then crocoite. The minerals are found in gold-bearing quartz veins traversing granite or gneiss in the type locality, and quartz, embryite, phonochrocorite, and vacuolinite are associated with crocoite. Phonochroite is a deep-core red lead chromate, Pb2CrO5, and vacuolinite is a brown or green monoclinic lead and copper phosphate chromate, Pb2CuCrO4PO4OH. Vacuolinite was decided to name after Louis Nicholas Vauquelin, who explored the element chromium in crocoite in 1797 at the same as well as autonomously of M.H. Klaproth. The extended mine at Mount Dundas and also the Adelaide, Red Lead, West Comet, Platte, and a few other Dundas mines have widely available masses of extraordinary crocoite crystals. They are typically found in long and slender prisms, normally about 10 to 20 millimeters in length, but hardly ever up to 100 millimeters in length, with a fantastic sparkle and color. Crocoite is perhaps the state mineral of Tasmania. Congonas de Campo next to Ouro Preto in Brazil, Luzon in the Philippines, Mutare in Mashonaland, near Menzies in Western Australia, as well as Brazil, Germany, and South Africa have all produced well-crystallized specimens. Crocoite's relative scarcity is due to the unique requirements needed for its creation, which is an oxidation zone in a lead ore bed, as well as an occurrence of ultramafic rocks that serve as chromium sources in chromite. The oxidation of Cr3+ forms crocoite into CrO42 and the decomposition of galena and other primary lead minerals. This is an unusual set of circumstances. Crocoite is dangerous because it is made up of lead chromate, which contains both leads as well as hexavalent chromium. Mike and Eleanor Phelan have been mining crocoite from Tasmania's Dundas Extended Mine since about the mid-1980s, but the mine dates back to 1892 when that was used as a silver-lead prospecting tunnel. The mine is for sale as of April 2019, with the owners owning and operating the surrounding Stick-Tight mine. Number 1. Azurite. Weathering of copper ore deposits produces azurite, which is a delicate deep blue copper mineral. Since prehistoric days, the mineral Cu3CO32OH2 has been known as a carbonate with the chemical formula Cu3CO32OH2. The intense and clear blue of azurite has long been caused by low desert and winter skies. The Mohs hardness ranges from 3.5 to 4, and thus the specific gravity ranges from 3.773 to 3.78. Jewelry. Azurite is now and then used more as a stone for beads and jewelry and as an ornamental stone. However, its soft texture and natural tendency to lose its deep blue color as it ages have fewer applications. In addition, because azurite is easily destroyed by heat, all azurite specimen mounting must be carried out at room temperature. Collecting. Azurite is a prominent collectible rock due to its intense color. However, the idea that specimens should always be thoughtfully guarded against the bright light, warm air, and open air to maintain their color intensity over time could be a myth. Azurite is stable under normal storage conditions, according to Paul E. Desotel. Prospecting. Since azurite is not really a significant copper ore, it is a gold surface indicator of the presence of eroded copper sulfide ores. It's mostly encountered with the chemically similar malachite, resulting in a remarkable color palette of deep blue and bright green that's highly suggestive of the involvement of copper ores. If you want to see more videos like this, please consider subscribing for more.